Welcome to Module 3 of Multi-Agent Architect. In Module 2, you built a sub-agent, hand-authored, installed, and triggering a real piece of working software. Congratulations! That's already further than most people get. But here's the truth Module 2 didn't tell you. One sub-agent is a worker. It's not a system. The moment you try to scale that worker, give it reusable knowledge, automate things around it, hand users a clean way to invoke it, you discover the agent isn't enough on its own. You need the rest of the toolbox. That toolbox has 4 primitives. Agents you already know. The other 3 are skills, hooks, and / commands. Each quick check on whether you're in the right room for this module. Card 1. You shipped a sub-agent. Not in theory, in practice. It's installed. It triggers on the right tasks. You have a transcript proving it auto-fired the way Module 2's assignment asked you to demonstrate. If that's not yet true, pause this and finish Module 2 first. The composition layer in this module won't make sense without something to compose. Card 2. You can feel the missing pieces. The agent does its job, but you've started noticing the gaps around it. There's procedural knowledge you keep pasting in by hand. There's a guardrail you wish was always on, but isn't. There's a prompt you keep typing the same way every time. Each of those gaps maps to one of the primitives we're going to learn. Card 3. You're ready to compose. One agent is the noun in your sentence. You want the verbs, what runs before, around, and after it. You want the agent to stop being a one-off invocation and start being a node in something larger. If 2 of 3 describe you, this module is the right level for you. If only one fits, you might want to spend another week with Module 2 before the composition mindset takes hold. 3 concrete things you'll be able to do an hour from now. 1. The 4 primitives. You'll know exactly when to reach for an agent, when a skill is the better tool, when a hook is the right shape, and when a / command is what the moment calls for. More importantly, you'll know when not to reach for each one, because that's where most of the bad systems get built. 2. Working examples of each. Not abstractions. A SKILL.md you'd actually ship. A hook script that does something useful. A / command that dispatches your Module 2 agent. We'll look at real code in real shapes. You can copy the patterns directly. 3. A composed mini-system. All 4 primitives wired together, so they coordinate. This is the prize. The first time the work feels like a system instead of a script. The composition is the lesson. One primitive learned in isolation is half a tool. The agent without the skill without the hook without the command, each of those is fine, but none of them is what people pay money for. The system is what people pay money for. So we're going to build one. The map of the territory in 2x2 form. Top left, agent. The verb is decides. An autonomous worker reads the inputs, reasons about them, takes actions, returns a result. That's the unit you built in Module 2. Tools, model, system prompt, its own context. It thinks. Top right, skill. The verb is knows how. A skill is procedural knowledge, a how-to file loaded on demand by a trigger phrase, reusable across agents and across sessions, borrows the caller's context, doesn't get its own. Bottom left, hook. The verb is autoruns. Deterministic glue. Fires on tool events, on prompt submissions, on session lifecycle moments. No reasoning, pure code. Same input, same output, every time. Bottom right, command. The verb is invokes. A / command is the user-facing entry point. / name, arguments. Auto-discovered. Often dispatches one or more agents. Sometimes dispatches a skill. Sometimes just injects a prompt. For words you'll come back to 100 times in this course. Decides. Knows how. Autoruns. Invokes. If you can place a piece of work into one of those 4 buckets, you know which primitive to reach for. If you can't, that's a smell. Usually it means you've conflated 2 pieces. Part 1. The plugin primitive map. We'll spend the next 6 slides on choosing the right primitive for the job because the rest of the module assumes you can. Same 4 primitives in table form. Read it row by row. Each row is a different lens on the same thing. Agent. Capability is decision maker. Scope is one task or pipeline at a time. Trigger is routing. The orchestrator decides to call you based on your description, or another agent calls you explicitly. Skill. Capability is procedural knowledge. Scope is reusable across agents. The same skill can be activated by 10 different agents in 10 different sessions. Trigger is the trigger phrase or file pattern. The runtime detects a match and loads the skill into context. Hook. Capability is deterministic automation. Scope is tool calls and session events, narrow, well-defined moments in the lifecycle. Trigger is one of 5 lifecycle hooks: pre-tool use, post-tool use, user prompt submit, stop, or session start. Command. Capability is entry point. Scope is the user's invocation. Trigger is the user typing / and the command name. Read row by row. Capability tells you what the primitive provides. Scope tells you where it applies. Trigger tells you when it activates. 3 lenses for primitives. That's the entire conceptual map of the layer we're working in. Decision tree. 4 yes or no questions. First yes wins. Question 1. Does it need to make decisions? Reasoning, routing, judgment calls, context-sensitive choices. If yes, you want an agent. Question 2. Is it reusable procedural knowledge? A how-to invoked by a trigger phrase that can be loaded into multiple agents' contexts. If yes, you want a skill. Question 3. Is it event-driven and deterministic? Fires on tool calls, prompts, or lifecycle moments, no reasoning required, just an explicit allow block or modify. If yes, you want a hook. Question 4. Is it user-invoked from the CLI or chat? / prefixed. Auto-discoverable. Light by design. If yes, you want a / command. First yes wins. If 2 questions seem to apply equally, that's a smell. You've usually conflated 2 pieces of work into one. The fix is to split them. Give each piece its own primitive. Then they can compose. This is the tree I run through in my head every time someone asks me, should this be a skill or an agent? Or should this be a hook or a command? I don't carry it on paper anymore. It's worth memorizing. Agent versus skill is the confusion that eats the most time. Let's resolve it. An agent has its own context, its own session, its own model, its own tools, its own system prompt. It's a whole worker. When the parent dispatches an agent, the agent gets a fresh context window, does its job, returns a summary. The reasoning trace is gone the moment it returns. The cost is the tokens it burned plus the dispatch overhead. A skill borrows the caller's context. It doesn't get its own session. It's loaded into the active conversation as procedural knowledge. The agent who triggered the skill is the agent who reads it. There's no separate model, no separate tools. Hook versus agent is a different axis. The determinism axis. Hooks are deterministic. Same input, same output, every single time. Pure logic in your shell. The hook reads STIN, runs your code, prints a JSON return on stout, and the runtime acts on it. Allow, block, or modify. There's no judgment involved. There's no LLM in the loop. Hooks are the place to put guarantees. Agents are probabilistic. They're LLMs reading context and deciding. They reason. They handle ambiguity. They make judgment calls. Sometimes they get it right. Sometimes they don't. That's the trade-off. A / command is the doorbell. The agents inside answer the door. That metaphor saves you from the most common / command mistake, building a / command that does the work itself. 3 things to know about / commands. They're discoverable. Typing / auto-completes available commands, so the user doesn't have to remember names. They're argument-aware. Anything after the command name lands in $ arguments, available to the body. And they're light. Almost no logic of their own. Their job is to hand off. If your slash command's body has more than a paragraph of logic in it, you've built an agent and called it a command. The fix is to lift the logic out into a real agent and let the command stay light. The command names the agent, passes the arguments through, and gets out of the way. That separation matters because slash commands aren't designed for reasoning. They're designed for invocation. The reasoning lives in agents. The procedural knowledge lives in skills. The deterministic lives in hooks. The slash command is the front door. It doesn't know what's happening inside the house, and it shouldn't. Visualize a session as a Part 2. Skills. Procedural knowledge subagents can reuse. The single most underused primitive in the 4. A skill is a folder with a SKILL.md file at the top. 2 halves, the front matter contract and the body. The front matter has 3 required fields. Name, in kebab case, like an agent. Description, which is the trigger field. The router reads this to decide whether to load the skill. And allowed tools, which whitelists what the procedure inside can reach for. Same principle of least privilege we covered for agents. The body is plain markdown. The actual procedure. Step 1, Step 2, Step 3. Things to watch for. Edge cases. Pointers into deeper references when needed. The body is what the agent reads. Trigger language for skills follows the same playbook we covered for agents in Module 2. Lead with the user's words, not yours. 5 rules. 1. Lead with how the user would phrase it, not how you'd phrase it as the skill author. The user who'll trigger this skill probably doesn't know it exists. They're going to type something natural like ship my plugin or package and publish. 2. List 3 to 5 phrasings the user might type. The router pattern matches. More anchors mean more reliable matching. Don't be precious about elegance. List them in plain language. 3. Add concrete domain anchors. Words like Gumroad, plugin, manifest. These give the router something specific to lock onto. Abstract verbs alone, process, handle, manage, won't trigger reliably because they apply to everything. 4. Avoid abstract-only phrasings. Process this. Handle that. Everything is processing. Everything is handling. The router can't tell what you mean. 5. Ask yourself the simple test. Would I actually type this? If the answer is no, the router won't match on it either. If a user wouldn't say it, the router won't match on it. That's the whole rule. Sticky note it on your monitor. Progressive disclosure. The most important pattern in skill design that nobody tells you about. The SKILL.md body itself stays tight. You want it to load cheaply on every match. Trigger language at the top, a scannable procedure overview, maybe 150 words, and pointers into deeper references when the procedure needs them. Skills get loaded a lot, especially well-triggered ones. So keep the SKILL.md tight, like a good system prompt. The deep stuff lives in a references folder next to SKILL.md. Detailed how-to documents, edge case playbooks, troubleshooting guides, templates, and schemas. Loaded only when the skill folder layout. SKILL.md at the top. 3 subfolders below it. References. Markdown files that the procedure points to when stuck. Manifest schemas. Field reference docs. Pricing playbooks. Loaded only when the procedure asks. Scripts. Executable files the procedure runs. Build scripts. Verifiers. Anything you'd rather invoke than re-explain in prose. Bash, Python, whatever, the agent just runs them. Templates. Files to scaffold from. README templates. Product page templates. The procedure copies them, fills them in, and moves on. Treat the whole. Wait. The skill calls the agent? Yes. The skill is the recipe. The agent is the chef. Most teaching material treats skills as something an agent reaches for, and that's true, in one direction. But the relationship runs the other way too. A skill can be the orchestrator, and agents become the workers it dispatches. We call this the inversion pattern, and once you see it, you'll start using it everywhere. Trace the flow. Step 1. The user says package and publish my plugin. Step 2. The router activates the package and publish skill because that's what the trigger language matches. Step 3. The skill body says dispatch the manifest validator agent. Step 4. The agent runs, returns a verdict, pass or fail with specifics. The skill reads the verdict and either proceeds or halts. Step 5. If proceed, the skill says, now dispatch the Gumroad uploader agent. The skill never thinks for itself. It just routes. The agents do the thinking. The skill is the wiring diagram. Why does this matter? Because it scales. A single skill can orchestrate 3 or 4 specialist agents, each one narrow, each one cheap, and the user gets a clean, reusable workflow. That's a system. And it lives inside what looks like a single skilled MD. Live build, in summary form. The package and publish skill, 3 steps. Step 1. Verify. Read the manifest. Check the required fields, name, version, description, license, repository URL. Fail fast on errors. The procedure does this by calling script/verify_manifest.py, pure Python, deterministic, no LLM involved. If it fails, the skill stops and reports back. Step 2. Build. Zip the folder into an archive. Tag the artifact with the manifest version number, Semver discipline, so updates work later. Again, this is a script. The final decision rule. In one question. Does this need its own context to think, meaning a separate session, separate tools, separate model? Or can it borrow the caller's? If the answer is own context, it's an agent. The work needs its own session because reasoning depends on context the caller can't share, like exploring a deep codebase or running a multi-step pipeline that would blow up the parent's window. If the answer is borrow, it's a skill. The work is procedural, just teach the caller how to do the thing. Drop a how-to into the active conversation. Let them call it from inside their own context. If the answer is unclear, if you can imagine doing it either way, the answer is Part 3. Hooks. Deterministic automation. The smallest, most powerful primitive in the 4, and the one most teams ignore until it's too late. 5 lifecycle events. Each one is a precise moment in the session. Your code runs. You decide allow, block, or modify. Session start. Fires once when a session opens. Setup work, load config, check authentication, prepare a workspace. One shot, before anything else happens. User prompt submit. Fires every time the user submits a prompt. Use it for routing, for keyword detection, for prep-ending context that the user shouldn't have to remember to include. This is the busiest hook in most setups. Pre-tool use. Fires before every tool invocation. The guardrail. Block dangerous operations. Valid. Every hook prints the same JSON shape on stout. For fields, the runtime parses it and acts. Continue. Boolean. Does the parent agent keep going after this hook returns? In most cases, yes. You return continue false to halt the parent, for example, after a session start hook that fails authentication. Suppress output. Boolean. Hide the hook's stout chatter from the user. Useful when the hook's output is internal, formatting messages, log lines, and you don't want the user to see it. Decision. The verb. 3 values. Allow lets the action proceed unchanged. Block stops it cold. Modify lets you rewrite the input, change the bash command, alter the prompt, transform the tool arguments before it executes. Reason. A short string. Surface to the user when you block. 200 characters or less. Be specific. Refused. Dangerous bash pattern detected is useful. Blocked is not. Print this object on stout. Every hook obeys the same shape. Same contract everywhere. First use case. Pre-tool use hook that blocks dangerous bash patterns before they run. Read the input on stin. That's where the runtime hands you the tool invocation, JSON encoded. Use JQ to pull out the command field. Then the meat of the hook, a regex match. If the command matches a dangerous pattern, rm-rf/ fork bomb syntax, sudo rm, print a block decision with a short reason and exit. Otherwise, print allow and exit. 8 lines of bash. That's the whole hook. Why is this the right shape? Because never run rm-rf/ is not a judgment call. It's a rule. Putting the rule in an agent system prompt makes it probabilistic. Sometimes the agent listens, sometimes it doesn't. Putting the rule in a hook makes it deterministic. The pattern matches or it doesn't. The block fires or it doesn't. There is no sometimes. Cheap to write. Impossible for the agent to skip. Always on guardrail. This is the kind of guarantee that hooks were built for, and the kind of work you should never give to an LLM. Second use case. Post-tool use hook that auto-formats files after every write or edit. Read the file path from the tool input. Dispatch on extension. TypeScript? Run prettier. Python? Run black. Go? Run goffent. Each one a single shell line. Suppress output so the user doesn't see format chatter. Why does this when over telling the agent to format? Because the agent will forget. Not always. Most of the time it will remember, but most of the time isn't always. And every time it forgets, your codebase drifts a little. Multiply that across hundreds of edits and your formatting is inconsistent. The hook makes Third use case. User prompt submit hook that routes prompts based on keyword matches. Read the prompt off stin. grep for security-related keywords, security, vulnerability, CVE, OWASP. If matched, return a modify decision that rewrites the prompt to mention the security auditor agent explicitly. If not matched, allow it through unchanged. The runtime treats the modify decision seriously. The user typed one prompt, the agent sees a different prompt. That's powerful, and it's easy to abuse. Use it sparingly. The user should still feel in control of what their words do. If your hook is rewriting prompts in non-obvious ways, the user will start to feel like the system has a mind of its own, which is exactly the opposite of what we want. 2 rules of thumb. Modify when you're adding. Wiring lives in settings.json. Each lifecycle event has an array of hook script paths. Order in the array equals priority. 5 rules to internalize. 1. Order equals priority. The first hook listed runs first. If your block dangerous bash hook comes before your log tool call hook, the block fires first. Planned accordingly. 2. Any block decision short-circuits the chain. If the first hook says block, the rest of the chain doesn't run. Useful for guardrails. Once you've decided to block, you don't need to keep computing. 3. Hooks within an event run synchronously. They're a chain. Each one waits for the previous to finish. So latency adds up. 4. Different events run independently. A pre-tool use hook doesn't share state with a post-tool use hook unless you write to a file or environment variable. 5. Keep the chain short. Every hook is latency. 200 milliseconds doesn't sound like much until you realize it fires 50 times in a session, and now your user is waiting 10 extra seconds for nothing. Guide deliberately. Profile end-to-end. Don't add a hook unless you're sure it earns its place. 3 anti-patterns I see again and again. LLM in a hook. The temptation is to call a model from inside the hook. Use haiku to decide whether this bash command is dangerous. Don't. If you call a model from a hook, you've reinvented the agent at the wrong layer. The whole point of hooks is determinism. The moment you add probabilistic reasoning, you've lost what makes a hook. Lift the work into a real agent instead. Silent state changes. Hooks that mutate things without telling the user. The auto-format example I described earlier is borderline. Most users find auto-format helpful and don't mind that it ran. But a hook that, say, Part 4, /commands, the user-facing entry point, the lightest of the 4 primitives, and the most often misused. A /command is just a markdown file. That's the whole format. It lives in .claude/commands, with the file name being the command name. So to claude/commands/review, MD becomes /review. Auto-discovered, drop the file in, and it shows up in tab completion immediately.
No registration, no config, no setup.
The front matter has 3 fields. Description, which powers the tab completion hint and tells the user what the command does. Allowed tools, which whitelists what the inline prompt and any dispatch subagents can reach for. And model, which sets the default model for the inline prompt. Subagents pick their own. The body is the prompt that gets injected when the user invokes the command. Plain Markdown. Anything you type in the chat box yourself can be in the body. That's the whole format. Markdown file with front matter. Same shape as agents and skills. By design, the layer is consistent across the 4 primitives, which means your muscle memory transfers. Once you've written one, you've written all of them. Argument parsing. The $sign argument's variable. Anything the user types after the command name lands in $sign arguments. It's a single string, whatever was after the slash and the name. So if the user types /explain src/auth/session ts, then $sign arguments holds the path src/auth/session ts. You reference it in the body. The example here is a /explain command that reads a file at $sign arguments and explains it in plain language for a non-engineer, capped at 200 words. The body is 2 sentences. The arguments do the rest. Treat $sign arguments like a single string. If you need structured arguments, flags, positional args, named keys, parse them yourself in the body or hand off to an agent that knows how. Keep the / command thin. Don't try to build a CLI argument parser inside a markdown file. Most commands you'll ever write use $sign arguments as a single string in one place: the file path, the search query, the topic to expand. That's the 90% case. The other 10% gets dispatched to a real agent that can parse properly. 2 dispatch shapes for / commands. Light handoff and full orchestration. Each one is appropriate in different cases. Light handoff. The body is 1 paragraph. It names the agent it's calling and passes $sign arguments through verbatim. That's it. Most commands look like this. /explain hands off to an explainer agent. /review hands off to a reviewer agent. /summarize hands off to a summarizer agent. The command is the doorbell. 1 agent answers the door. Full orchestration. The body explicitly says dispatch in parallel and lists multiple agents. The classic example is /review, security auditor, perf reviewer, and test runner all dispatched simultaneously, each one looking at the same code from a different angle, and the results aggregated into one synthesized report. Default to light. A / command that dispatches 1 agent is the right shape 90% of the time. Reach for orchestration only when 1 agent isn't enough, when the work genuinely splits into independent subtasks that benefit from running in parallel. The smell of an over-orchestrated command is when you find yourself dispatching 3 agents to do work that 1 agent could have done with 3 subprompts. That's a single agent's job, not a parallel dispatch. / command front matter. 3 fields. Identical shape to agent and skill front matter.
Description.
What the command does in 1 sentence. Tab completion hint comes from this. The router can also use it for ambiguity resolution if the user types something that could match multiple commands. Treat it like the description field on an agent. It's the most important field in the file. Allowed tools. The whitelist for whatever runs inside the command body. Same principle of least privilege we've covered for agents and skills. If the command's body asks the inline prompt to read files, you list read. If it dispatches a subagent that needs bash. Live build. /review. 3 reviewers in parallel. 12 lines of markdown. Front matter. Description. Parallel review across security, performance, and tests. Allowed tools. Read, grep, bash. Model, sonnet.
Body.
Dispatch in parallel. Explicit signal to the orchestrator. List 3 agents. Security auditor on $sign arguments. perf reviewer on $arguments, test runner on $arguments. Each gets the same target. Each works in its own context in parallel. Closing instruction. Aggregate findings. Deduplicate. Rank by severity. The orchestrator does this synthesis after the parallel dispatch completes. It sees 3 returns, merges them, sorts by severity, and gives the user one combined report. The command is 12 lines. The agents do the work. The composition, 1 orchestrator, 3 workers, parallel dispatch, dedupt aggregation, is what makes this a real command and not just a wrapper around 3 sequential prompts. That's the shape. 12 lines of markdown for a parallel review pipeline. Once you've seen this pattern, you'll find dozens of places to use it in your own work. Now we get to the composition layer. The whole reason you're in Module 3. The mini-system pattern. 1 agent at the center. 3 primitives around it. That's the structure of the simplest real system you can ship. The agent is the thinker. The reviewer you built in Module 2. It does the actual reasoning, reading code, evaluating against criteria, producing a verdict. A / command provides the invocation surface. / review. The user types it and the system fires. The command is light. Its job is to hand off to the agent. A skill provides reusable knowledge. Your team style guide. Your security checklist. Your performance heuristics. The skill loads when the agent's context activates its trigger phrase. The agent reads the skill and uses it as criteria. A hook provides deterministic guarantees. Auto format runs after every write or edit. The agent doesn't have to remember formatting. The hook makes it inevitable. Each piece does one thing well. None of them is doing another's job. The agent thinks. The skill teaches. The hook automates. The command invokes. The composition is what makes them a system instead of 4 files in a folder. That's the pattern. 1 + 3. For primitives for roles. Memorize it. End-to-end walkthrough. 1 invocation. Watch the 7 things that happen. Step 1. The user types /review src/auth/session ts. Step 2. The / command body fires. It dispatches the code reviewer agent, passing the path through. Step 3. The agent activates the style guide skill. The trigger phrase in the agent's reasoning matches the skills. Use when reviewing code, pattern. The skill loads into context. Step 4. The agent reads the file. It evaluates against the style guide it just loaded plus its built-in security and performance heuristics. Step 5. The agent writes a diff with fixes via the edit tool. Step 6. The post tool use hook fires. Auto format runs on the edited file. The agent doesn't see this happen. It's invisible. The file is now consistently formatted. Step 7. The agent returns a structured object back to the parent, verdict, issues array, summary. The parent agent reads the return and decides what to do next. Each line is a different primitive. Together, they're a system you couldn't build with any one of them. The / command alone wouldn't know how to review. The skill alone wouldn't apply itself. The hook alone wouldn't fire without an agent's edit. The agent 6 checks for whether what you've built is a composition or a stew.
1.
Each primitive does one thing. The agent thinks. The skill teaches. The hook automates. The command invokes. None of them is reaching into another's territory.
2.
The agent is the thinker. Skills, hooks, and commands are the wiring. If your skill is doing reasoning, that's an agent. If your hook is doing reasoning, that's an agent. If your command is doing reasoning, that's an agent. Lift it. 3. The / command is light. No logic inside the body, just dispatch. If the body has more than a paragraph of substantive logic, you've built an agent and called it a command.
4.
Hooks are deterministic. No LLM calls inside them. If you're tempted to use haiku to make a decision in a hook, that's a signal to make it an agent instead.
5.
Skills load by trigger phrase. They're reusable across agents and sessions. If your skill is hardwired to one agent, It's probably part of that agent system prompt instead. 6. Failure of one primitive doesn't cascade. Verify between handoffs. If the agent's diff is wrong, the auto-format hook still ran on a wrong diff. Make sure the agent's verdict gets parsed before the parent moves on. 6 checks. If you can answer yes to all 6, you have a composition. If you answer no anywhere, you have a stew with delusions of grandeur. Quick recap of what an hour of Module 3 has given you. You can now do 5 things. Pick the right primitive, agent, skill, hook, or command for the kind of work you're trying to do. Author a SKILL.md with proper front matter and trigger language that the router. 3 concrete actions. 3 time horizons. Pick the one you can commit to.
Today.
Sketch the 4 primitive map for your Module 2 agent. On a single page. Which skill does it want? What knowledge would you offload? Which hook? What guarantee should be inevitable? Which/command? What's the right invocation surface? 30 minutes of sketching will save you 10 hours of building the wrong thing. This week, ship the SKILL.md, the hook script, and the /command. Wire them in settings.json. Run /your command end-to-end and capture the transcript. That's your assignment artifact. 5 gotchas to expect on your first composition. Each one has happened to me. I'm just trying to save you some hours.
1.
Skill activates on too many phrasings. Your description is too broad, too generic, and the router loads the skill in contexts where it has nothing to contribute. Symptom. Every subagent invocation has the skill in context, and your token bill goes up for no benefit. Fix. Tighten the trigger phrasings. Add domain anchors.
2.
Hook silently mutates files. Your auto-format runs, your linter rewrites things, your formatted changes whitespace, and the agent